Hello everyone. Now I am here with my next topic of data structure, that is binary. In this I want to tell you about tree traversal and one more thing, that is different terminology of tree. In my previous video I told you earlier that something basic about trees, and now I'm going to revise you first of all what is tree, then I'm going to proceed further with the binary. Tree is a set of points and a lines, is a combination of set of points and lines where the points are known as vertex of trees and lines were known as edges of trees. In trees there is not more than one edge to connect pair of nodes. It is also known as simple acyclic graph. In tree there is a special designated node known as root node. Always the structure of root tree start from root only, and the degree of root is 0. Always remember, degree of root is 0. And one more thing I want to add in this, in each tree with n nodes there will be maximum of n minus 1 edges. Now see, in given tree A is a root node, each and every circles were vertex of trees, or we can say they are nodes. Each and every line we used to join two nodes were edges of trees. See, if we are going to count the number of nodes, count the number of nodes. A is 1, then B is 2, C 3, D 4, E 5, F 6, G 7, H 8, I 9, J 10, K 11, L 12. Means total 12 number of nodes, means n number of nodes is 12. And if you are going to count the number of edges, then see, between A and B we are having one edge, then A and C 2, then A and D 3, B E 4, C F 5, C G 6, D H 7, H I 8, D I 8, D J 9, GK 10, and GL 11. Now see, we are having 11 edges for 12 nodes. Now proceeding further, see, first of all binary tree. I told you about binary tree also, but for revision I am telling you again. It is a special tree in which each node can have maximum 2 childs. Means each and every node have their children. In previous, if I am moving backward, see, A is the root node having child B, C, D. Means A is parent node, B, C, D were child nodes. Now again moving further with the binary tree. See, maximum 2 nodes a parent can have. Maximum means a parent can have 1 or 2, or maybe didn't have any child, means 0, 1 or 2. That's why see, we are having either 0, 1 or 2 child nodes in binary tree. Either we can say they are having left subtree or right subtree, means left hand or right hand. Now see, binary tree is in front of you all. A having 2 nodes, left node and right node. But if we are going to have tree, again we are having a tree with us. See, this one is a tree. It is left sub tree. And this one is right sub tree. Each and every node have left and right subtree and right subtree. And again, if we are talking about B is root node, then this one is left and this one is right. Left subtree, right subtree. Again, if I am talking about C, if C is root node, then E is left subtree, and this part is right subtree. Means each and every one is having left and right, but sometimes we are having some nodes that doesn't have any child, then that node is leaf node. Now proceeding further, features of binary tree. Few points you have to remember about binary tree, that is, number one, binary is a non-linear data structure. I told you earlier also, in any format it can increase. Means it doesn't have that left subtree will be increased or right subtree will be increased. Any order is not fixed for trees. A binary tree contains only one root node, because every tree structure have one root, and then only it can proceed further. That's why always the starting point is root node. Means each tree have one root node. Then each node contain two children at most. A node can have only one parent node. You have to remember, each node have only one parent node. A predecessor node means a child node cannot be a child node of a successor. Predecessor cannot be a child node of successor. Means predecessor means if I'm writing A, B, A is parent node, B is child node. Predecessor means this. Successor means this. A predecessor node cannot be a child of successor node. Means we are not supposed to move like this. We have to move like this. A is parent, B is child. Child can't be a parent node for a parent of a given child. And then root node doesn't have any predecessor node. Predecessor means parent node. If we are having a starting node A and we are moving further with the different nodes, A doesn't have any parent right now. That's why root node doesn't have any predecessor node. Now leaf node never have any successor node. Why they are not having any successor? Successor of a child, and leaf node doesn't have any child. Now moving further. Now see, traversal of binary tree. It is a topic inside the binary tree where we can visit our nodes one by one in a particular order. How? We are having three orders. Number one is prefix. Pre means we are fixing root in front of left and right. Left and right both are subtrees. See, now we are having tree in front of us. We have to place root first, then left subtree, and then right subtree. It is a basic order. Now we are having A as root node, and now see how we are going to do that. First of all, it is left part, it is right part. And the same order we have to follow in for each and every node, because we are having so many subtrees inside a tree. That's why we have to follow the same process for each and every tree. For example, in front of you all, you are having one tree, then you are having another tree, that is left subtree, then you are having right subtree. If I want to denote, then this is also a tree, this is also a tree, this is left, this is right. If I want to say this one is also a tree, this one is also a tree, this one is also a tree. That's why each and every places we have tree, and we have to follow the same process for each and every tree. Means firstly we have to write root node. Now we are having root node, then everything in place we have to place here left subtree. Every material of left subtree we have to place here. Every material of right subtree we have to place here, one by one. But what we have to remember, the arrangement, root, left and right. How we are going to write? See. Now, A is root, this is left subtree, this is right subtree. Now what to do? Each and every tree have its root, left subtree and right subtree. Now if we are focusing on this tree, it is a left subtree. And in this we are having a root node, that is C. That's why we have to write root, left and right. How we are going to write? C is root, then left part is H, then we have to write H. That's why I'm writing C, H. Red color for root. Now again we are having tree inside it. Inside it we are having one more tree, and again we have to follow the same rule, root, left, right. In this tree we are having a root that is D. That's why I'm writing D here. After D I have to write root and then left. Left is G. And then right. Right again we are having tree. F is root. That's why I have to write F. And then root. After root, left. Left is having I. Right. They didn't have any right root, any right node actually. That's why I'm not writing another thing. That's why we are having these things in front of us. I'm denoting it like C is root node, then H is left, and other part is right. And again in another part, D is root, G is left, and right also have a tree. F is root, I is left, right is not present. In this way, every place you have to fill by keeping in mind the prefix order. Again, we have to fill right subtree here. How? This is our right subtree. Means E is root node. That's why I have to write E first. Then left part is not present. That's why ignore it. Then we are having right part. In right again we are having tree. That's why B is root node. Then left, then right. In this way we are having our prefix order for tree traverse. Now combinedly you have to write answer. Then moving further with next traversal, that is infix. Infix, you all know, root is fixed in between left and right. The same tree we are having in front of us, where we are having root, left subtree and right subtree. Here we have to place left subtree first and then root, then right. Same thing you have to do. Now A comes in between both of them. And then here we have to fill left part, here we have to fill right part. Now, slowly we are moving further. Left subtree is this, right subtree is this. How we are going to write one by one? See, if I'm writing left subtree first, then what I have to write? See, left subtree contains C as root node. That's why I'm writing C. Then, but C as root node. But C should be in center. That's why I have to write in center. Previously, we are writing C here because root is present in left side in prefix. Now, we are dealing with infix. That's why we are writing A in between both of them. That's why we are writing C in center for left subtree. And then left part is H. Means left subtree contains H only. But right subtree contains 4 nodes. Here we have to write 4 nodes. But it is also a tree. That's why D should come in between. And the left part is G. Right part is also a tree. That's why F should be in between. But left hand side we are having, right didn't have. That's why whatever we are getting as left subtree, that is HCG DJF. And we have to write this in C. Now, if I'm talking about right subtree, then it is the right subtree. How we are going to deal with it? Here we have to write right subtree. Right subtree, E is root node. We have to write in center. Left part is not there, leave it. Put right part. Right part is also a tree. That's why B is root node. Left part we are having, that is I N K. Means what we have to write in place of right subtree, that is EIPK. Now see what I am getting. The same thing. H is left, C is root, G is left, D is root, J is left, F is root, A is root, E is root, I is left, B is root, K is right. In that way you have to write each and everything. Now you have to write answer completely. Now moving further to the third one, that is postfix. Post means in last you have to write root. Same tree we are having, root, left subtree, right subtree. Now, firstly we have to deal with left subtree, then right subtree, then root. Now we have to write root in last. How? See, in this way. In everywhere we have to write root in last. Now we have to proceed with left subtree. In every left subtree we are having node, that is root node. But root node comes in last. Here we have to write left subtree, then right subtree, and then root. But see, left subtree contain H and right subtree contain 4 nodes. That's why what I have to write? Here I have to write only H. And right subtree contain 4 nodes. Means left, right, root. Left is G, right again tree. Means in this I have to find left, then right, then root. But right is not present. What I have to do? If right is not present, what I have to do? Nothing I have to write. Left, right, root. In this way, you have to write J and F only. Means if I'm writing, see, I'm writing A here, I'm writing H is left, left, right. Right is tree. Then again left, left is G, right is FJ, but it is also a tree. Again we have to write left first, that is J. Left, right is not present, leave it. Then root is F. Then what? Left right part is over, left and right part is over. Then what? Root D. Left and right part is over. Then what? C. This is our answer. HGJFDC is our left subtree. Maybe you can find it complicated, but if you are trying to do it, you can definitely do it. If I'm talking about right subtree, how I'm going to deal with it? Every right subtree contain node, that is root node. In last, firstly we have to deal with left and then right. We are not having left. See, we are not having left here. Then we have to deal with right only. Right is also a tree. In last we have to write root. Firstly we have to write left part first and then right part. We are getting as right subtree, that is I, K, B, E. The same way, see, I am putting the answer one by one. H is left part, G is left part, J is left part. Left part first, then root. See, again here we are having root first. We are not having left part, that's why we are writing root first. Then here we are having left, root, left, right, root, left, right, root. And in last we have to write root. In this way you have to write one by one each and everything in the complete answer. Now proceeding further with the tree terminology. In this tree terminology, you are getting so many things one by one, but few things were coming in your paper and you have to find it out from the tree. But few, the basic details you have to know, you have to keep in mind, that is node. Each and every circular thing is node. Node is a structure which contains a value. Now value is in front of us is capital A, capital B, capital C. Each and everything for nodes. Means all circle what we are having is nodes. Edge, a line which is placed in between two nodes to join them. That line is edge. Root node, you all know, it is the first node or the topmost node of a tree. It doesn't have any parent node. Example, A is root node for a given tree. Now leaf node. Leaf node, or we can say terminal node, or we can say external node, doesn't have any child. Means HIG, all are child node, doesn't have already, they all are child of HI are child of F, G is child of E, but H doesn't have any child, I doesn't have any child, and G doesn't have any child. That's why all of them doesn't have any child. What do you mean by child and what do you mean by parent? Actually, when we are having a node, for example A is having B and C, means from A we are moving towards B and C. A is the parent node, B and C were child node. The same way, F is parent node, H and I is child node. HIG doesn't have any child, that's why they are leaf node. Then we are having internal nodes, that is non-terminal nodes. It is a node that has child nodes or nodes. We can say a particular thing, a parent, all parents' nodes were internal nodes. Means A, B, C, D, E, F, all are internal nodes. Siblings, when one parent have two children, then both of them were siblings. Nodes that appear from the same parent. See, B and C were siblings. H and I were siblings. Weight, coming towards weight. Weight of tree is number of leaves nodes. We are having 3 leaves nodes. That's why the weight of tree is 3. Now moving further. Depth of a node. In brief, I am going to explain in the next slide depth, height, level. 3 things combinedly. Because sometimes we are going to confuse between the 3 things: level, depth and height. First of all, depth of a node. It is a number of edges from root node to that node. Maybe we are having a last leaf node. We can have number of nodes. And depth of root is 0. How? I can explain it further in next slide. Level, you have to keep in mind few things, that is the root node always starts from 0. The level of root node is 0. Then the next line will 1. The next line 2. Then 3. Then 4. How? See, this is level 1 in this way. First level we are writing as 0. The second level we are writing as 1. Third level we are writing as 2. Fourth level we are writing as 3. And this one is fifth level. We are writing as 4. Means A belongs to 0th level. This is our 0th level. Then this is our first level. This is our second level. This one is our third. And this one is our fourth level. In this way, we are having levels. Same as depth of node. Each and every node, this one is depth of root node is 0. Then 1. Then 2. Then 3. Then 4. In this way, we are moving further. Now, subtree, you already know. Each and every parent have some child, and child were behaving like a tree. Then they are subtrees. And they can be said as descendants. The child nodes were the descendants. And each and every node, maybe they were the root node for other tree. It can be possible. Now, subtrees were of 2 types. I told you earlier also, left subtree and right subtree. This one is left, and this one we can say it is right subtree. Now moving further, height of a node. It is a number of edges from the node to its the deepest leaf of the subtree. The height of leaf is 0. The height of root is the number of edges from the root to the deepest leaf. I'm going to explain height, depth and level from my next slides. But one thing you have to keep in mind, height of root, height of tree, depth of tree, all were equals to the number of edges in the longest path of a tree from root to leaf. And what about longest path? See, if I'm talking about longest path, that A then B D F I is the longest path. A B D F and H is also a longest path, which contain how many nodes? 1 2 3 4 5. 5 nodes. Means in this way we are having 5 nodes. Other path we are having 4 nodes. Means the longest one 5. And now see, one thing which we have to discuss is about level, depth and height. In a previous slide, I am going to provide you only notes, and in next slides you are having a description of these three things, that is level, depth and height. Level, I told you earlier, A 0th level, B C 4th level. Different example I am taking so that you can identify what I am telling you. This one is 0th level, then 1, then 2, then 3. In this way, any of the tree can move further. Then, after that, we are having depth. Then we are having depth. Now, the same thing I told you, each and every level and depth was same. See, 0th, 1. These were a second level. These were a third level. The depth and level were same. But what about height? Is it same? No, it is not same. Height of A is the number of counting what we are doing. From leaf node, see, the height of leaf node is 0. Then the next one is 1. The next one is 2. The next one is 3. Height of root node is 3. You have to keep in mind, each and every leaf node height is 0, but depth is 3, level is 3. But when we are talking about root node, height is 3, depth is 0, level is 0. That's why I'm writing it, combining all three things together so that you can keep things in mind. If I'm talking about level of tree, level, depth and height of tree right now, see, all were same. 3, 3, 3. Height of tree is 3, depth of tree is 3 and level is 3. That's why we can write in this way also, that all of them were of same value. And now see, I'm moving further with these things so that you can keep all these things in your mind. And now I'm moving further with more terminology, that is number 1, that is size of a tree. Again, another terminologies we are having, size of a tree means number of nodes present in a tree. You have to count them and you have to write it. Then parent node, I already told you in detail. Then predecessor, parent node is a predecessor of child node. Child node, you all know. See, these details, you all familiar with it. Successor or descendants for the child nodes. Each and everything I had already given explanation for that. Predecessor, child is a father node or a parent node for a child, and successor or descendant is the child node of a parent. Now see more terminology, that is path. The number of nodes or edges from one node to another node is a path between both the nodes. If I'm talking about path between B and I, then B, D, F and I. In that way you have to move further. If I'm talking about the longest path, then A, B, D, F, I, 5 nodes were there. That's why the longest path. Again we are having one more path. See that we are having two paths of same number of nodes. That's why we have to consider both of them as longest path. Then we have degree. The total number of children of a node we are having, that is degree of node. Degree of F is 2 because F have 2 child. That's why the degree is 2. In degree means number of edges coming to a particular node, that is in degree. Means F getting one line inside it from D. The number of edges coming towards F is in degree and F is getting only one. Out degree, the number of edges comes from F towards the another nodes, that is out degree, and we are having two nodes which is connected with F. That's why 2 as out degree. Now one practice question is in front of you all so that you can practice 3 things, that is prefix, infix and postfix, and write your answer as comment in this video's comment section. And if you have any of the doubt, do consult with me. But few things you have to keep in mind. Theoretical material you have to keep in mind and do practice whatever is provided. And if you have any doubt, do consult with me. Otherwise, goodbye and good luck.